Hello, I welcome you to the introductory lecture of Basic Thermodynamics. After this lecture, you will be able to answer what is thermodynamics, what are the application areas of thermodynamics, what are the approaches to solve thermodynamic problem, and what is system. Now let us begin. Thermodynamics can be defined as science of energy. It is difficult to give precise definition of energy, but energy can be viewed as ability to cause the change. The word thermodynamics is a Greek word which is made up of two different words, in that one is therm and another is dynamics, where therm means heat and dynamics means power. In brief, thermodynamics is study of generation of power with heat. In recent context, the definition of thermodynamics is changed. But in early 19th century, the motive behind study of thermodynamics is to generate power from hot bodies or measure the capacity of hot body to develop the work. Today, the scope of thermodynamics is larger, dealing generally with the energy and properties of matter. Now let us look into the application areas of thermodynamics. Thermodynamics is branch of physics and engineering science both. In physical science, scientists are normally interested in gaining the fundamental understanding of physical and chemical behavior of matter at the rest, and uses the principle of thermodynamics to relate the properties of matter. Whereas in engineering science, engineers are generally interested in studying the system and how they interact with the surrounding. To facilitate this, engineers extend the subject of thermodynamics to study system through which the matter flows. All the activities in nature involves some interaction of mass and energy both. Thus, it is hard to imagine an area that does not relate with thermodynamics in some manner. Therefore, developing a good understanding of basic principle of thermodynamics has been essential part of engineering education. Thermodynamics is commonly encountered everywhere in life, like pumping of blood in your body, heater, refrigerator, air conditioner, etc. And this is not over yet. All the automotive vehicle, airplanes, jet engine, nuclear power plants, solar plate collectors, etc. Now, let us understand the various approaches to solve thermodynamic problem. There are mainly two approaches to solve thermodynamic problem, in which one is microscopic approach and another is macroscopic approach. If we talk about microscopic approach, usually it is called as statistical thermodynamics. In this approach, thermodynamic study is concerned with the structure and behavior of all the individual molecules present in system. The objective of statistical thermodynamics is to characterize by the average behavior of particles making up the system. That is why solving the engineering problem with this approach is quite difficult, and the application of statistical thermodynamics are laser, cryogenics and plasma. This approach is also useful in generating data like specific heat of ideal gas at various temperatures. And now, if we talk about macroscopic approach, usually it is considered as classical thermodynamics, which is concerned with the overall behavior of the system. Because of this, analysis becomes easier. That is why this approach is widely used in engineering science. For example, if you go to doctor to check your blood pressure, he will measure the blood pressure using sphygmomanometer. Here, doctor is measuring your blood pressure, not the pressure of individual molecules in your blood. For more understanding, if one need to measure the pressure of gas filled in the container, it would be sufficient to attach a pressure gauge to the container. This approach does not need detailed information of all the molecules. Now, let us talk about system. An important step in engineering analysis is to describe precisely what is being studied. If we talk about a problem in engineering mechanics to find the motion of body, normally the first step is to draw free body diagram and identify all the forces acting on the body. Afterwards, we apply the Newton's second law of motion, but in thermodynamics, the term system is used to identify the subject of analysis. A system is defined as quantity of matter or the region in space chosen for study. Once the system is defined, the relevant interactions with other systems are identified and one or more physical laws or relations are applied. It may be as simple as the cube of ice or as complex as the oil refinery also. We may want to study the quantity of matter within the closed rigid wall tank or a pipeline through which natural gas flows or the flow through heat exchanger. The mass or region outside the system is called as surrounding, and the real or imaginary surface that separates system and surrounding is called boundary. The boundary of system can be stationary or moving. For example, consider a potato, then the boundary of potato is fixed. That is why it is called as stationary boundary. And if you look at the boundary of piston cylinder, it is continuously moving because your piston is continuously moving. So this type of boundary is considered as the moving boundary. The interaction of system and surrounding take place across the boundary, and it is essential to define boundaries very carefully. Boundary can be differentiated by real and imaginary also. For example, consider the boundary of water tank. The boundary of water tank can be considered as real boundary, and if we consider nozzle to be our system, it is open from both the ends. So we need to imagine the boundary such as this type of boundary is called as imaginary boundary. After defining system and boundary, it is so important to observe the interaction between system and surrounding which is taking place across the boundary. And this interaction can be in form of mass as well as in form of energy. Based on the interaction across the boundary, the system can be classified in three categories. In that, one is closed system, second is isolated system, and third is open system. Now, consider a system which is having only energy interaction with the surrounding but no mass interaction. This kind of system is called as closed system. Here, no mass is crossing the boundary, but energy in form of heat or work can cross the boundary. For example, consider a tightly closed piston cylinder device. And let us say we would like to find out what happened to the enclosed gas when it is heated. Since we are focusing our attention on gas, our system is gas. The inner surface of piston cylinder forms the boundary. It is interesting to observe that this boundary is moving boundary and the real boundary. And since no mass is crossing the boundary, this is called as closed system. Notice that here energy is crossing the boundary in form of heat, and the part of boundary may move because of the expansion of gas. Everything outside the gas includes the piston cylinder as the surrounding. This is the example of closed system. Because there is no mass transfer across the boundary, but there is the energy transfer in form of heat. Now let us talk about isolated system. Isolated system is the special case of closed system. A closed system in which there is no energy transfer, in another word, there is no transfer of energy across the boundary either in form of heat or in form of work. Example of isolated system is a thermos flask. Here, no water will cross the boundary and there is no heat transfer or any work transfer across the boundary. Now let us talk about open system. Consider a case where system is defined in such a manner that mass is coming into the system and mass is going out from the system. Here mass is crossing the system boundary as well as energy transfer is also taking place across the boundary. This type of system is called open system. And pump is the example of open system because it sucks the water and delivers to the certain height. But it is interesting to observe that the boundary of pump is imaginary and fixed boundary. Here, mass is crossing the boundary of pump and energy transfer is also taking place in form of mechanical energy. So, pump is considered to be open system. Open system is used interchangeably with control volume and the boundary of open system can be called as control surface. And sometimes closed system is called as control mass system.
After understanding this lecture, one should be able to answer what is thermodynamics, what are the application areas of thermodynamics, which are the approaches to solve thermodynamic problem, and what is system. In upcoming lecture, we will talk about properties of system, state, equilibrium, process, and cycle. Thanks for watching this video.